Thanks for joining Michael and I today to run through an update to sort of give everyone an idea of some industry activities that are ongoing, sponsored by the Linux Foundation. So the ELISA, Enabling Linux and Safety Applications, is a sub-foundation of Linux Foundation that anyone is welcome to join and collaborate in. And um, Next slide, Michael. I think you'll see here we have a lot of good diversity just within us too. I, I'm hailing from the Boeing company. I have a career in embedded electronics and Linux for the last 17 years or so. And at Boeing now, I lead our Linux for both aerospace and defense type of products. And I'm currently chair of the ELISA committee on aerospace.
And I'm Michael Monaghan. I've been working with embedded Linux systems in space for a little over 8 years now at Goddard Space Flight Center. Hand it back to you, Matt.
That's good. Next slide. So ELISA is an interesting group of working groups. You'll see in that green bubble that it's comprised of a set of core groups that focus on the engineering life cycle. So you have the process, the systems, the architecture, the critical features and functions of that thing that we're building. And then you have the tooling and these days you also have like the AI ML and all the static and dynamic analysis pieces of that come from the tooling front. So you have these different groups working together, and originally they were assembled for the automotive space. And then medical, I think about the same time, joined with automotive within the first year. And about 2 years ago, aerospace joined as a formal group. And if you think about just between automotive, medical, and aerospace, that jumps between at least three major safety standards, and they all vary in the way that they approach it, and in the impacts vary and the hazards vary too. So it's interesting dynamic on, I think we have rail and some civil infrastructure type things as well engaged in this and looking at their use cases. So this past year, aerospace worked to incubate the space special interest group, which is what you'll hear more about in the talk today. But if any of these groups look like they have an interest to something that you're focused on, I do encourage you to reach out to one of the references we have later in the slides, or to Michael or I, and we can get you hooked up with the working group cadence as well as contacts. So next slide. So for the working group that I chair specifically, we're focused on developing the use cases that help drive those other groups within ELISA. So we're trying to assemble the technical requirements for avionics specifically and look at where that crosses with open source technologies, processes, and toolings. So it both goes from the real high assurance you could see like flight controls on a commercial aircraft, all the way to something that's like controlling a cabin light, say in a bathroom. So broad range of use cases we're working on, and we have a white paper in progress as well that sort of talks about current state of industry. So we go into a lot of that in more detail in our 2024 and 25 briefing that we just did, and QR code and links are here. Next slide. The Goddard workshop was sort of the end of a progression last year where we were starting the space grade interest group. And at that event, it was really interesting to look at the existing ELISA groups like automotive and some of the work done on requirements and verification, bringing their conversation, as well as vendors and industry people sharing. The link to the actual content from that's there in the bottom corner, and it was just really diverse, and I think the conversation was really interesting. And all of us that couldn't attend in person were incredibly jealous after the fact, because I think the tours were pretty cool, and the content was great too. There is a workshop coming up next week that I believe will have a virtual component. So if you are interested in general ELISA content as well as space, there are going to be some talks at that, and the links below we'll get you to the page where you can subscribe to the other events. Next slide. So here's just a brief snapshot of what was talked about in that workshop. The workshop was that chartering event for space grade Linux. And the one thing I'll bring attention to is there was an interest survey. And that interest survey on space grade Linux is really interesting to look at where the industry participants wanted that group to steer. And I think the trend that we're seeing is that space grade Linux will be more boots on the ground with real content, managing fragmentation of technologies, providing examples and tangible things you could leverage into your product or program spaces. So that's in comparison to the aerospace working group, where we're more defining the bounds of the use case or scenario, and then using that to help inform like what space grade Linux would be looking at. So other talk on here that's interesting was Tim Bird's building an OSS ecosystem for space. Tim was one of the early advocates talking a lot about the fragmentation that some of us have seen. And this is just an environment where I'd encourage you to, I think next slide, I'd encourage you to meet join the meeting on the third Thursday of each month, to bring your flavor to the conversation and to help us navigate how that community needs to move forward. So the QR code and the link here will get you to an invite that's open for anyone to join. And Ramon usually sends the agenda out a few days in advance, so you sort of have an idea of what's going to be discussed. So with that, I'm going to hand it over to Michael, and he's going to deep dive into the space grade Linux.
All right. Thanks, Matt. Quick mic check. Can you guys still hear me?
Yep.
Assume that's a yes. Great. All right. So yeah, thanks for the workshop. To the workshop as well for the opportunity to speak about the space grade Linux effort here, which I believe has some roots in last year's flight software workshop. So I should address the elephant in the room here. Why are we talking about Linux? And there's a lot of different reasons. Number one, it's free and open source. That's free as in speech, not just free as in beer. And there's an enormous user base already familiar with Linux that comes with an unparalleled software ecosystem. You'll often find first-class embedded hardware support, and I could argue that it's the most reviewed and researched operating system in the world. It's also, I think, the most performant option, and at least on modern processors. And as of September last year, you can support many hard real-time applications out of the box without any of the famous preempt RT patches. Those, I think it's been mentioned at least 3 times now, those are now merged into the kernel. To be clear, I'm not saying Linux is a replacement for RTEMs or VxWorks or other RTOSes, but it can handle some applications previously reserved for RTOSes. And even then, it may not still be appropriate, but we'll see. This is the future we're working towards. So, show of hands, who's flying Linux? How about who wants to fly Linux? Show of hands. I'm going to pretend everybody's hands up in the room. I can't see anybody. So, and if I recall correctly from the HPSC talk, there was a specific ask. They wanted, I think it was students and industry said they wanted essentially a laptop running Python in space. And well, Linux can provide much of that. So here's a few examples. In space, my favorite are Ingenuity and Falcon 9, both using Linux to run software for actuator control. Pretty impressive stuff. There's actually an excellent presentation on how Linux was used on the Ingenuity Mars helicopter. Remind me, I can leave a link in the Slack. Oh, and lastly, Linux might be the most deployed OS in space. Tim Bird over at Sony loves to quote the exact number. I can't quote it. He does. He pays closer attention to it than I can, but I believe right now it's more than 40,000 Linux nodes are flying in space, courtesy of Starlink. On Earth, automotive and telecom industries are using it for safety critical and high reliability applications. I liked on the telecom side, if you've got an Android phone, it's no surprise you're running Linux. If you've got an iPhone, you're not running Linux, you're running the X and U kernel, but your Qualcomm 4G, 5G modem is running Linux. So there's no escaping Linux. You already depend on Linux every day, and I believe with a solid foundation, you can depend on Linux to run the software on your spacecraft. So what's SGL? Space Grade Linux. It's a collaborative open source project bringing together space agencies, industry, and academia to establish a trusted ecosystem of Linux-based open source software for mission critical spacecraft operations. That's the way I like to describe it. And it's funny, this thing has actually been tried before, but in the automotive industry. The inspiration comes from the Automotive Grade Linux Project, or just AGL. Uh, and automotive software development used to be chaotic and fragmented, a lot more than it is today. And as open source projects do, AGL brought competitors together to develop common open source software to produce a higher quality product at less cost than a single organization could achieve alone. The project grew and eventually adopted a governance structure with technical steering with a technical steering committee. And I imagine one day, if Space Grade Linux is successful, this could happen, where a Space Grade Linux technical steering committee could consist of members from organizations who might be attending today. Also, I like to point out that AGL also indirectly benefited other industries that use Linux. That's a kind of side effect that NASA especially loves to see and sometimes brag about. So switching back to Space Grade Linux, what is its purpose? Like Chris said on day one, developing in isolation, it's a challenge, and you've only got one shot in space. So we should stop reinventing the wheel and collaborate on a solid ecosystem to reduce cost, time, risk, by tapping into the collective knowledge base, leveraging our unique core competencies. For example, I bet I know more about Linux than anyone in the room. Granted, I wouldn't be able to say this if I were attending in person. I've got the office to myself here. But kidding aside, people who know flight software frameworks might not know the ins and outs of everything Linux, and they don't necessarily need to. Next, we all know the pleasure of finding new ways to deploy complex, high performance next gen software in space, and Linux opens the door to using off the shelf open source libraries often with bleeding edge solutions, so we can reduce lag time to adopting new technologies in space. We can be the leaders again rather than waiting for the technology to mature. Let's see, how am I on time? Take, for example, a spacecraft having more data that can be downlinked. You could run a Jupyter notebook kernel on the spacecraft, and a data scientist on Earth, well, of course they're on Earth, a data scientist at home can remotely process the data on the spacecraft, given you have enough processing power, using the tools they're already familiar with. Lastly, rather than verify every permutation of Linux, we can just verify a few tailor-made for space and eventually inspire confidence through flight heritage. So here's the elevator pitch. I like to illustrate space grade Linux as a rocket, where the payload is your mission specific flight software. From the perspective of the mission software developer or the payload designer, SGL intends to help you focus more on your flight software and less on the underlying infrastructure. A payload designer doesn't need to worry about how the rocket works. And the space grade Linux rocket tackles bootloaders, different kernel versions, kernel patches, kernel config, device trees, distribution policy, libraries, dependency resolution on those libraries, dependencies on those libraries, system daemons, executables. The list goes on. There's a huge configuration space here. On the flip side, from the perspective of the space grade Linux developer or the rocket builder or rocket scientist, SGL offers the vehicle, no pun intended, for anyone to share and contribute to the full stack implementations or methodologies to support flight software. So that's a lot. How do we facilitate collaboration on a project like this? Well, the answer is the Yocto project and Open Embedded, or rather, I should say that's the best answer we've got right now. And this is collectively just termed Yocto. In short, Yocto offers the build system and the interface to make those full stack contributions I just mentioned, and it also happens to be the solution that AGL has adopted. The interface I'm talking about is a lot of you already know. They're called Yocto layers, and they're just modular repositories, just a directory that can be pulled into any project using Yocto. And I couldn't help but think a lot of the work we've heard of at the workshop could be released in Yocto layers and subsequently integrated into space grade Linux, for example. I know HPSC is working on a Yocto layer offering hardware support. You could integrate the various update mechanisms we've talked about in the last couple of days, possibly even tying into the bootloader. Support for GPUs, test frameworks, AI accelerators, cybersecurity policies, new cryptography, almost anything. And there's also already a huge ecosystem of existing software there's a huge ecosystem of existing layers for common software and hardware. Most of these are published at layers.openembedded.org, but a lot of them they might be proprietary. You might have to pay license for, or just private. Over at layers.openembedded.org, you can find support for all the common software like the Xilinx boards, Raspberry Pi, BeagleBoard, software like TensorFlow, Python, ROS, you name it. And there is a fantastic community that's rallying behind Yocto right now, and it's become the de facto standard across industry, or is becoming, if it isn't already. So to summarize, SGL encapsulates three main areas. Broadly speaking, the way it works is the community develops software and configurations or distributions tailored for space applications. Then the community develops, tweaks, or tests hardware support that runs that software. And I say tweaks because sometimes a BSP won't be targeting high reliability environments, for example. And then finally, the community comes together and evaluates that software and hardware implementation to verify safety and security. So as Matt mentioned, the ELISA project, they have a special interest group in the ELISA project over at the nonprofit Linux Foundation. And they're incubating space grade Linux and offering a place for discussions and pull requests. Right now, we're migrating from, or they are migrating from the planning phase to an initial pull request phase. The repo, I'll just talk a little bit about the repo. The repo is governed by an MIT license, and it has a developer certificate of origin. It actually doesn't have a CLA, which is a famous hurdle in many organizations. And it actually meets the procedural requirements me see, it's NPR 2210.1e, which allows civil servants to make rapid contributions to qualifying third-party open source projects. This is a relatively new carve-out that really enables NASA to contribute to society as a whole in areas that aren't just space or governed by ITAR or export control. If you're from NASA and you want to talk more about that, I can put you in contact with some folks who can better explain those aspects. And yeah, just because we're collaborating on common software doesn't mean we have to do everything the same way. Traditional Linux distributions, they know this, and they offer flavors, spins, or additions for different compute environments and user preferences. For SGL, or space-grade Linux, I'm proposing the concept of constellations. I hope you like that name, but it makes sense. Constellations are just different configurations that primarily address user preferences such as the flight software framework, but could also address overall system design decisions. Think of there being constellations for CFS, F prime, Space ROS, and maybe different ways of running those. And in Yocto, it's really easy to switch between those different distribution configurations. It's just a matter of setting one variable. So currently I'm working on what I'm calling right now as the CFS1 constellation. The name will make sense in a bit. It's a bare bones Linux distribution with an absolute minimum software bill of materials tailor-made for running CFS. It's intended to be a starting point for future development, and I hope it catches on. Here, CFS is the primary process, running as PID1, otherwise known as init. I like to think of this as think of the way CFS is running here as a middle ground between running on a classic desktop Linux distribution and an RTOS. But why is this important? Going back to what Rich mentioned in the CFS talk, we have to validate every open source component. And I know a lot of other organizations probably have to do the same thing as per NPR 7150. And minimum SBOM and kernel config really makes this approachable. Boeing's actually also working on a minimal kernel config, which I plan to integrate, and I think would be a fantastic addition. But this is still Linux. Standard libraries and executables can be leveraged. Especially since spacecraft usually don't have an IP networking stack, CFS acts as the sort of, or CFS apps, I should say, act as the middleware between commands and telemetry and typical Linux application interfaces, UDP, command line interfaces, you name it. But going a step further, CFS1 could even be extended to running standard Linux containers like we saw earlier, RHEL. Taking advantage of the rich ecosystem and reputation that RHEL has garnished over the years. And heck, CFS1 could even host a virtual machine through the kernels, the various frameworks available through the kernel. I'm still working on a release, testing in QEMU and common boards. Love to get my hands on an HPSC board to test this out. We'll see where that takes us in the future. But yeah, that's a little bit about space grade Linux. I'd love to hear some feedback. I'm going to switch back to Matt to talk a little bit about the resources on the ELISA side.
Yeah, I think we're a little over time, so I'll leave you guys with these links. And I think if you start anywhere, drop something on the mailing list, or feel free to directly reach out to me via like an issue ticket on the Git repository, or something like that. I think we're really flexible, but would love to hear from you.
All right.
All right. Thank you, Michael and Matt.